I really want to explore some examples because, it's great that we know the theory, but the best way to study for the MCAT is to do these practice questions. So basically in me explaining the tip to tail method, this is pretty much the extent of what we're going to get here. So just understanding how we connect these two vectors together. So the tip to tail, it's in the name. So we literally connect the tip here of one vector to the tail of the next, and then the resultant vector is going to be spanning this entire distance. Now, let's dive into an example where we use the components method. I'm just going to switch up my color to a nice yellow here. Let's say we're trying to find this vector right here. So this vector, we can call it A. So let's call this vector A. Now, vector A is going to have two components. It's going to have its, say it with me, it's going to have its horizontal and vertical components. So I'm drawing the vertical component first. I'm going to call this Y, so vector Y. And then it's also going to have its horizontal component, and we're going to call that vector, so vector X, for example. So that's vector X. Now, a very typical question would be, something like, given this angle here. So let's say we have this angle. This is the symbol theta. So let's say, given that this angle is equal to 30 degrees, and what's something else? And the magnitude of vector A is equal to 10 meters per second. And I'm trying to think here. Is that all we're going to need? Yeah, that's all we're going to need right now. Yeah. So given that we have, sorry, I'm just doing this on the fly. So let's say we have this angle right here, and we have this magnitude right here. What is the question might ask, what is the components of this vector? So what is the vertical and what is the horizontal components? Well, the question here is asking us to find the magnitude of vector Y and the magnitude of vector X. So the first thing we need to do is we need to keep track of what we have. Okay, so what we have is we have angle theta is equal to 30 degrees. We know the magnitude of vector A, so here's vector A, and we're talking about its magnitude, is equal to 10 meters per second. We do not know, so what we want to know, we want to find the magnitude of vector Y, so we don't know this, and we want to know the magnitude of vector, that's too curved, and we want to know the magnitude of vector X. So these are the two things we want to know, and we're trying to find this information given the information that we have. Now, if you haven't seen the other two videos I've posted, so it's part 1 and part 2 where we cover the basic math foundations, those two videos are really, really important in solving this problem. So I'm going to proceed as if we already have watched them, we already understand it, but if you haven't watched those videos, and what I'm about to do will make a lot of sense. So, first we need to talk about this thing called SOHCAHTOA. So SOHCAHTOA, what is that? This is kind of like a mnemonic to help us out with trigonometric functions. So basically, it's a way to help us find, the magnitudes of sides of right angle triangles as well as the angles within them. So right now, basically what this means is depending on what angles we have, or depending on what sides of the triangle we're trying to find, we're going to apply these different SOHCAHTOA methods. And I'm assuming you already have a good understanding of trigonometry. If not, there's a lot of great resources out there. Just literally type in SOHCAHTOA into the internet and you'll find a great video, I promise. So, but that being said, we're going to cover it as if we don't really understand what's going on. So I'm going to break this down. So this S stands for sine. So it stands for sine theta. Sine is just one of the trigonometric functions. Again, check my other video if you haven't. This stands for opposite. So this O stands for opposite. Now the opposite, so that refers to a side of the triangle. So that is going to refer to the side that is opposite of the angle in question. And in this case, the angle that we're talking about is this theta is equal to 30. So that's the angle. So the opposite is going to be the side that is opposite to the angle, which in this case is our vector Y right here. So I'm just kind of outlining it in white. This is our opposite. Now this h stands for the hypotenuse. And the hypotenuse is the longest side on a right angle triangle. It's going to be vector A, and I'm just highlighting it in white right there. Now, the only other time, and that goes for all of these. So this h here means hypotenuse, and this o means opposite. This c refers to cosine of theta. This t refers to tangent of theta. So this a refers to adjacent. So just a quick recap: S, C, and T stand for sine, cosine, and tangent. A stands for adjacent. O stands for opposite, and H stands for hypotenuse. Now, in this case, we have the angle, so we have angle theta, and we also have this hypotenuse. And what we're trying to find is the opposite, and we're trying to find the adjacent. So it is really up to us which one we want to solve for first. I'm going to solve for the opposite side first, so I'm going to use this SOA. I guess I should have said so. I'm going to use so first. So we have sine, I did not spell sine right. Sine of theta is going to equal to opposite over hypotenuse. And that's what that means. And, we can kind of fill this in with the information that we have. So we know angle theta is 30 degrees. We don't know the opposite, but we know that it stands for vector y. And we do know the magnitude of A, which is 10 meters per second. Now what we can actually do is multiply out this 10 meters per second, multiply each side by 10 meters per second, and we're left with 10 times sine 30 is equal to the magnitude of vector y. Now, if you watched my last video, you would know that sine of 30. See, in our last video, we covered this table and how we can make this table. So we know that sine, so here's sine of 30 is equal to 1 over 2. Okay? It's pretty much that easy. Once you know how to make this table, it gets much, much easier. But basically for now, sine of 30 is equal to 1 over 2. So let's go back down. We can replace sine 30, so 10 times sine of 30 is equal to 1 over 2. And that is going to equal to the magnitude of our y vector. So, we can just say y vector is equal to 5, because 10 divided by 2 is 5 meters per second. That is the magnitude of our y vector. So we can actually just erase this question mark because we now know the answer, and we can say 5 meters per second. Now we want to find the magnitude of the x. Since x is the adjacent angle, or it's the adjacent side, we're going to use cosine. So we're going to use CAH, C-A-H. This is going to be cosine of angle theta is going to equal the adjacent over the hypotenuse. This is just me reading off the SOHCAHTOA thing. Let's add in what we know. We know theta is going to be angle 30 degrees. The adjacent is going to be the x vector, and hypotenuse is going to be our a vector, which is equal to 10. So we can multiply each side by 10. And before we move to the next line, let's check this graph here that I showed you guys how to make in a previous video. Let's go to cos of 30, which is right here. So here's cos, here's 30. That's our answer. So we're looking for root 3 over 2. So we can replace cos of 30 with root 3 over 2. So what we have here is we have 10 times root 3 over 2 is equal to our x vector. We can cross out this 2, and we can cross out this 10, replace the 10 with a 5. So the magnitude of the x vector is equal to 5 times root 3 meters per second.